I would like to go over with you over the encryption solution for columns in the IBM I that we Raz-Lee provide. This presentation will be a bit different from the others in this series because it is going to be a little bit more specific with consideration or technical consideration and programming issues. So if some of you feel that it is a bit too complicated, simply wait until I go over to the next slide, which hopefully will not be that technical. Thank you. Okay, so among our solutions, we have the encryption, and in the encryption we have two parts. One is the field encryption, which is encrypting columns or fields as they were always called in the IBM I environment. And we have another solution, which is the PGP, which is file encryption. The difference here is that here we continue working with the application and we are able to show data within a specific field or column, either masked or clear text, while with PGP it's the idea that we are able to send a file to somebody else and he is able to receive it and knows that we sent it and he's the only one who is able to decrypt it and so on. Let's go to the first product, and this is the field encryption. With the field encryption, the need came from regulations. We have the GDPR, which is now very popular to speak about. The GDPR actually insists that we should protect personal information, and personal information to protect means encryption. PCI-DSS came earlier, and they insisted that we should encrypt credit cards. We have the HIPAA, which is the regulation for personal information, and again, similar thing, they insist that we shall encrypt personal information. And FDA and Part 11 and so on. So we are motivated by regulation. Regular use cases can be that we encrypt credit cards or other personal information, should it be medical information, etc. Some wishes to that we shall encrypt account numbers, ID numbers, social ID numbers. Of course, password we should always encrypt if instead of keeping the hash of them, we keep the full password due to some reasons. Usually when we speak about encryption, it is in cases where we found that it is insufficient to just restrict the access. Restricting an access is a good thing, but at the time that somebody finds a way to cross this barrier, then he can see everything. And if somebody makes his way to a backup, then with that backup he will find all the information. This is not the case with encryption. With encryption, even a backup doesn't include the clear text of the data. Usually when we speak about encryption, we see three ways of viewing the data. One is called clear text, where we see the full. This is an example of credit card. We have the ability to see it masked, which usually when we speak about credit card, it show only the last 4 digits. And with no data, this means just show a blank or dashes or anything. Regulation population, as one can imagine, starts from the United States, goes to Europe, Scandinavia, and is a bit less popular in other parts of the world. So red means heavy regulations, this color means a little bit less, and this less, and this is almost no. Field encryption characteristics. Well, it works with all kinds of application. It supports both DDS and SQL, which means even the traditional I/O will work and the SQL will work, and both it's not important if we have defined the file in DDS or in SQL. There is no need to move now to SQL in order to encrypt the file, a field in the file if it was created initially with DDS. Our implementation supports AES 128, 192, and 256-bit encryption. These are three types of encryption. Of course, this is the weakest one and this is the strongest one, but I'm going to surprise you and tell you that all of them are considered as suitable to encrypt top security data, top secret data, and they are adhered by the NIST, which is the National Institute for Standard and Technology in the United States, and so AES today is the standard. Usually, when we speak about encryption, the auditor, which will come and inspect deeply, and I've gone over several such inspection, they know that we should use at least 3 levels of keys, and these are the master keys, the key encryption keys, and the data key. This is at least, and we shall see our implementation. So everything which is written here is implemented by us. The way that we speak about encryption is usually in an organization. Now, the organization can be a single LPAR, but the organization can be as complex as having several tenses of LPAR. And the question is, where should I place the information? So the information is here always initially on the production systems, each of them, with its high availability, and we support high availability. Then the question is, where shall we put the keys? Because keys needs, like password, to be exchanged from time to time. So if we shall put the keys here and here and here, it is going to be a little bit of a headache because we shall have to visit each one of the LPARs when we wish to exchange the keys. It makes more sense to have a key manager and preferably put it on a different LPAR. It can be on any of these LPARs, but preferably on a different LPAR. And the idea is that, again, this provides another layer of security, because if somebody stole, let's say, all the backups of this system, he doesn't have the keys. So he will never be able to decrypt the data. And vice versa. If somebody stole all the keys, he doesn't have the data, etc. When we speak about encryption, there are two methods. One is called encryption, and one is called tokenization. The difference between them is where do we put the real encrypted data. Now, with tokenization, we can have another layer of security, and this shows another layer of security on a different LPAR. Preferably, of course, we can use tokenization and put it anywhere. Actually, every part can be on any part. It is sufficient to have a single LPAR which will have the keys and will have the token manager on it. That's okay. But the idea with the tokenization is that in the data itself, instead of us putting just standard the encrypted data here, we just put a token. A token is a simple number. Say that I have a file with 1 million records of credit cards, and I want to use a tokenization. So I will replace all the credit cards by the numbers between 1 and 1 million, and each one will represent a token, which if passed here, then this token manager knows what are the original credit card numbers, because there is a way to move them here, and the credit card numbers will be provided as per the rules which applies, and I will be discussing them later. So tokenization provides another layer of security, but tokenization is more complex. It's usually slower because it has everything that is in encryption, but it has to move another stage and so on. And sometimes it's more convenient because we may have just, we can move the data with just the tokens, and still here we shall have a single token manager which has the encryption of each one of all the LPARs in the organization. I hope this was clear enough, and if not, ask me later. So what we have here is just a summary of what I've just mentioned. So let's skip it and go further to the next slide. The field encryption keys. Now on the IBM I, there is something which is called part of the operating system, something that is called master keys. Master keys, which are just 1 to 8 master keys are possible, up to 8 master keys you can have on the IBM I. They are stored in the way that even QSEC offer is not able, even if you will dump all the memory of the IBM I, you will not be able to find out what is the key. The master key is stored in a place which is outside of the regular accessibility of the computer. It is actually stored in the service computer, the one which shows the running number when you IPL the system. So the master key is here, and it is used in our implementation to protect or encrypt something which is called organizational key, organization key. Now, the organization key is something that only us as an organization knows. And this is the only thing which enables us to transfer data between one system to another, because knowing that we are able to get to decrypt it in one place and get the original text. Because this is the way that we ensure that we are in the same organization. So the only secret of the organization is what we call the organization key. The master key, the one of the IBM, is used to encrypt the organization key, and the master key can be different on any system. Every system has its own master key which encrypts the organization key. The organization key by itself, it encrypts something which is called key encrypting keys, KK, and the KK is encrypting a data key, where the data key can encrypt the database data. The organization key is entered only once in every system, and it should be the same, and it should be kept in the safe of the organization. If it is lost, we shall not be able to restore it or to provide it. Data will be lost. Okay, let's continue. The master key of the system is a bit different from the regular keys that we use. The master key of the operating system has only 4 occurrences, which mean the pending one that we create, the new one which will be, the current one, and the previous one. So actually, because IBM has limited it only to 4 occurrences, the result is that every time that we change the master key, we have to re-encrypt the organization key. But thanks God, this is not what we lean on, because we lean on the data key, And in the data key, the way that we have created it is that we are able to keep as many versions, as many occurrences concurrently of the keys of the data and the keys which encrypt the keys, depending of course on your auditor, which may reject it and say that you should be a little bit more safe and so on and reduce some very old, etc. But it gives you at least the knowledge and calmness, because you are able to access any old backup, which is not true if we would have used only the master keys. So we have the ability to access every data, even if it is old. And should somebody lose his system on, let's say, entirely destroyed, inaccessible, crashed entirely, still no problem, because the organizational key is known. We go to another LPAR, we enter the organizational keys, we upload the backup of the key, the following keys, and everything is perfect. So there is no fear of losing data, and as I showed earlier, we do support high availability for every component in all cases. When it comes to encryption, it seems that everyone on the market shows you the same solution. We all today use the field proc. Field proc, something which was invented by IBM some years ago and started actually with release 7.1 of the operating system. I think it was TR4 when they started it. And yes, everybody uses field proc, except that most of the vendors had an encryption earlier. So their software has to support the earlier version and the new version of encryption. So their software might be a little bit, or actually much more complicated. But let's say that they have managed to work with it. Then it comes, everything the same? Not exactly. Let's look at the types of columns that Raz-Lee, with its iSecurity encryption supports, and with the other. So I assume that every provider can encrypt character fields, should it be fixed or variable length, that's okay. Numeric, the same. But when it comes to date and time, you will find out that not all providers can encrypt date and time field. And for example, today a timestamp is, or just a time field, is quite popular. So if you buy a solution, you want to be sure that it will support all your needs from now till the future, because it's very unlikely that you are going to change the encryption unless you fail hardly. So our solution does support it. Actually, I think that we are the only one in the market which support also blob and clob. Actually, you will, if you go to the web, you will find that it is impossible to encrypt clob and blob fields. This is not true. This is not true. And one of our clients, he keeps the salary slips of his employees inside a file on a clob field, or should it be a blob field, in ASCII, in a 2 million bytes field, and 2 million bytes field. You remember the record length maximum is 32K. Still, of course, salary slip should be encrypted. And we can do this. We even deal with null-capable fields. So every field type, which probably every field type or almost every field type that we have in mind, can be encrypted. The question with encryption is, what do we see? Do we see, how do we decide whether to show John the clear text? This is called clear text. How are we able to know that Mark, he should see when we speak about credit cards only masked data, while Dave, he should see nothing? Now, it can be that this is true for credit cards, but when we speak about something else, let's say personal information, then it's the opposite. Dave is allowed to see everything, but not the financial information regarding credit cards. Okay? So, the way that we do it is the following. For each subject, should it be credit cards, or personal information, or anything else, we have a decision table which is part of the software. And that decision table is based on user profiles. This table, we can, with it, the product can at real time, at the time that a record is accessed, determine whether to show the data as clear text, masked, or blank. In order to achieve this result, the user profile that is currently attempting to access that record, which contains the encrypted field, is received. And not only it, the user profile, not only him, but also all his group profile and supplemental profile, and we check them all in this decision table in order to be sure at the end that it is allowed for him to see the data in clear text. So this is the way that we work. This is good. This gives us the freedom to continue working with the software, and people will be able to see only what they are allowed to see. This is true even if the people are organized, or the users are organized using group profile in the organization. The question is flexibility, because we know that the 90% is achieved with 10% of the effort, but the rest 10% is usually very complex to achieve. But we have invested what it needs to invest, and we are able to give exceptions for this table of decision according to several other items. For example, we are able to analyze which program is using now the data, and if that program is part of, and if a specific program is part of the invocation stack, the call stack, then we are able to alter the decision and switch between one of these according to the program. In this way, the user who is not allowed ever to see the credit card, perhaps when he is receiving a phone call which is to change the credit card number, then and only then he is able to verify that the customer knows the full previous credit card number. This is just an example. Okay, so we are able to do this according to program name, according to we are also able to change the decision based on the display file or the record format of the display file. And of course, we provide a user exit program which can modify our decision, and we have even a command or an API which will set a time limit or number of counts, number of users by which the following IOs will provide an altered way of showing the data. Instead of continuing now with speaking, I prefer to make a kind of a break, and I will demonstrate to you how encryption de facto works. To do that, I will use our green screen implementation, and I will use two terminals simultaneously. This terminal shows the standard encryption product, which is now, by the way, being written for GUI, and hopefully we shall have a vast majority of it quite soon. And we shall have also a user named Mark, and Mark is the one who should see data as masked. So let's see first how data is encrypted and so on. I will go through this user, which is the major one, and I will work with the demo so I see the same screen. And when I go with option number 1, run query, then I see customer number is okay, and if I go to the right, then I see the full credit card number. Of course, all the information which you see comes from our mind. Nothing is real data. So you see the credit card number here. This is, by the way, the query of IBM. And this is the same with Mark. Because when Mark looks at the data, he see also everything like this, and if he scrolls, oh, look what happens. Mark is not allowed to see the credit card. Mark sees instead the masked version of the credit card. Why? Because his name is Mark, and the name of the user here is something else. And this user is allowed to see the full data, while this user is allowed only to see masked data. Now I'm using not an application which I have modified. I'm using now run query of IBM, a standard command, an ancient command. Actually, we can go out and try to see the same with different command. For example, why don't we take the standard IBM DFU? So we go with DFU with this user, and we see the data with all the details. No problem at all. We can scroll and see all the data. If we go with this user to the same file, seems that I'm not able to run it. Don't know why. Probably authority, so this is not a good test. Let's see something else. Okay, so let's take display physical file member. And if I go to the right here, I see the data. If I go to the one who is not allowed to see the data, and even in this display physical file member data, I see the data encrypted. Actually, in every way that I will look at the data, should it be file scope, should it be anything else like display physical file member or run query or even display journal, the one who is not allowed, Mark, who is not allowed, will not see the data, or he will see the masked version of it, while this user, the EN user, will see the full data. Why is that so? Because actually the encryption is done usually by this. This is the main screen. We have here the data manager. This is the part in which we decide what field we want to encrypt. We decide who will be allowed to work with it, and we decide exceptions, and we encrypt and do all the things. This is the area where we deal with keys. Here we enter the keys, we modify the keys, we re-encrypt, etc. And if we use tokenization instead of encryption in place, then we use the token manager, and this is different. And as I said and spoke about in the beginning, we are able to put each part on a different LPAR and let them all work in harmony. And this requires just getting here into the definition, coming into the general definition, and giving here the names of the key manager system and the token manager system. That simple. Okay, so when we get into this system, we shall take the fields to encrypt. We shall go to the business item, which is credit card. And in this business item, I can have any number of fields and from any number of files, and they all will be treated accordingly because they include information which is related to credit cards. And usually people which are allowed to see credit card in one file, they are allowed to see the credit card in a different file as well. So it's more convenient to work with it in this case. The definition is simple of a business item. It just says what is the data key that we are going to use for this field, for this business item, and we provide the authorization group. The authorization group is a name, or maybe first I'll mention that the last item is that whether I want it to work with encryption and tokenization. That's simple. While some of the other companies force you to work only with tokenization, which I do not support in most cases. I much prefer the encryption itself, but this is my own idea. Then here in this software you can easily decide. Of course, you are able to decide only before you have done the first encryption. Should you have done the first encryption, then this is protected and this is protected. Now the authorization group is very simple. This is the sale authorization group. Let's look at the sale organization group, authorization group. We go here, we look for sale. We get to see sale, and it is as simple as this. We can say, okay, user EN, he is able to see in clear text, while user Mark will see the standard mask. Again, user EN will see data for every field that has an authorization group of sale. In user EN will see it in clear text, while user Mark will see it in standard mask. So now that you know almost half of or all what has to be done, let's go into the field encryption. Let's go and take this, press another enter, and after I'm pressing the other enter, I come to see here, and I see that there were two fields which belong to this business item, which is called credit card, and it contains this field and this field. This field has already been encrypted, and this field is not encrypted yet. So let's get out of this file. It's not in this file, and hopefully I can have a exclusive lock, because it requires an exclusive lock to perform an encryption. So now I will encrypt also this field. It's not that complex. I just come here, I take this one. This is a notice. We are about to send a batch job, which will do the encryption. I send it, and he changed the status to pending encryption. And I press the F5, and I see here that the customer number is now encrypted as well. I go out, I go back to the same demo which I've showed you. If now I run the run query, I see that the customer number here is in clear text. And also, if I scroll to the right, the credit card on the left is also in clear text. But if I go to Mr. Mark and I take the run query, then the customer number is shown only partially. It's called masked. And also, the credit card is masked. So I think that this shows that to encrypt is quite simple if you know what you are doing. And this is true actually in all our life. And we are able to do this. What I can also show you that when I decide what to encrypt, I can go directly to the occurrences. I can go for each field, and before it is encrypted, then I am able to provide the mask which will be used when I use a standard mask, or the way that I will see the data when the data should not be displayed. So in order to make use of it, I can go here again to the occurrences of the data. I can decrypt this one, and he tells me, hey, there is another field. So if you want, we can decrypt them all together. So I decrypted them. The file is locked because somebody is using it here, of course. So I go here and I select decrypt. Okay, until previous submission. Work with last submission, and I can check with it. Let's not waste the time on it, but we have a nice control panel here, and we can press F5, and perhaps there is a message telling somebody get out, or there is an attempt to lock. But the idea, I think, is quite clear. Maybe it will be in place to just mention the exception groups. Now, in the authorization group, which we already saw the sale one, you can see that we have an exception. And the exception is everything user Mark, he is allowed to see data only in standard mask, but if I will provide here an exception group in batch or interactive, or just for interactive, I will be able to change it. Now, the exceptions group are here. An exception group can be either by the calling program, I give the name of a program, or by the display file record, the display file name and record format. And of course, I can have also a user exit program which will be called to investigate what to do with this field. So I will proceed with the presentation, and I will leave you enough time, hopefully at the end of my presentation, so that you can ask any question which you might have. So I'll try to be as short as possible with the rest of the presentation. So some of the characteristics of the system. We highly optimize the process. First, encryption is expensive. It's expensive in performance and expensive to some extent even in disk space. So you must know it. And we try to be as modest as possible. We are highly optimized to displaying the standard mask data. Standard mask is the standard, for example, for credit card, we all know it is show the last 4 digits, but it can be every second digit or every third digit, or anything which you might have in your mind. And knowing that in most cases the access to data are actually read. We read data much more times or many more times than we write it. So, and most people usually are allowed to see data as masked data. So because we don't do we do no decryption when we have to show masked data, then we highly optimize the system for reads of when masked data should be seen. If in the system there is a hardware cryptographic device, we will use it. And I think that the other things I've already covered, so we can continue. And when we speak a bit technically, you do not have to worry about any technical way. All the IBM command, even the database journal, are protected. The product can work, and the IBM solution can work with all the traditional I/O and SQL. The level check of the file doesn't change after you do encryption. You encrypt the field of which actually you don't have to recompile or do anything to your program. You just continue using, and some people will see the data, others will not. Now let's speak about some disk space consideration as well as some performance consideration. I'll appreciate if those of you who are making presently in some noise will mute themselves, and it will be much more convenient for everybody. Okay, I hope that you can hear me. I did it for us all. Okay, let's see the disk space consideration. Data, when it is being encrypted, it is the AES standard of encryption, which is the standard de facto in all the world, actually does the encryption in blocks. Now, it means that even if we have just 1 byte to encrypt, we need an additional 16 bytes of data when we use AES 128. It means actually a field of 1 character will require in the future 16 characters for its encryption. And if we use 256, we shall need 32 characters. So at the end of the day, it comes out, I gave here a nice table which you can investigate later, showing you what are the consequences of additional space used for each field based on the number of bytes which it is using. So actually, I made here an example. Let's say that we have a record of 200 bytes and 2 fields, each one of them is 10 bytes. And we decide to encrypt these 2 fields. If we do it with AES 128, then for each field, which is 10 bytes, we need 16 more bytes. So we finish up with 2 fields like this with 232 bytes. And if we go to AES 256, we will finish with 264 bytes. So nothing is cheap here. Disk space must be consumed for the encryption itself. And if the encrypted field is a key field, then the key field also requires additional space. So this is for you just to mention, to remember it. One of our customers made made a test on his environment. He encrypted many fields, and the result was that with some of the files, he got just 17% increase in the disk space, while with others, he managed to get to almost 80% increase. Okay? So this is the situation. Performance of CPU. Now, think, when you add encryption, it means that instead of just taking the data from the disk and providing it to the user through the application, then now we have to go through a process which will decide what way we should show the data, and also do what it has to do in order to decrypt the data or create the mask for it and show it. So of course there is an increase in the CPU, but you should understand, not all the applications are using encrypted data, and not everything is of encrypted data. And even if it is on encrypted data, when you use it a few times, like in an interactive application, you will seldomly even notice that there is a delay. On the other hand, if you have an application which reads all the file, and this is a huge file, and all that application is doing is just reading and updating the field which is encrypted, wow, this will take you longer. Okay? So to what extent longer? Do a POC. There is no other way to know about it. Simply take a small portion of the customer system, put it on a side library, encrypt, check the application on it, and see what is the result. Programming consideration. To some extent, in some cases, not that often, but existing, some of the customer application must be touched. And when I said touched, it means that usually very tiny. The idea is, the problem is because of IBM way of doing the encryption. The way that IBM is doing the encryption is the following. IBM decided that if an encrypted key, a key field is being encrypted, then the key order will not be according to the original value, but instead it will be according to the encrypted value. Which means, if I had until now 3 records, A, B, C, and every time that I access them, I could print them in a sequential order of A, B, C. Now I encrypt them. Now, being encrypted, it's something that no one can understand or imagine what will be the result. So now, if I will try to print them sequentially, I might get CAB instead of ABC. And in order to control situation like this, we must add something to some program. This is not common, this is not happening very often, but every customer here and there, he may come across it, and we assist, we have the knowledge how to deal with it. In our software, which I just demonstrated, we have a data, it's not important enough just to say, hey, we are able to encrypt. The question is what to encrypt. Because, you know, the regulator, the auditor, which comes on behalf of the regulator, he is interested to know that you encrypted all the credit cards. Should there happen a situation that a programmer copied a file to the side, then this is also considered a risk. So in order to find all the sensitive fields, you have two choices. Either you check and use the data discovery for GDPR and PCI, which is a tool that we have created. It runs only on the PC and provides a wonderful report showing you how many fields you might expect to be handling for your encryption effort, during your encryption effort. This is one thing. Or you can go with the tool which is part of the IBM product, and this is here circled, and this is find fields to encrypt. Now, it's very easy to find fields. It will prepare for you the list of fields that you need, either on the just from the discovery tool of the PC, or directly here from the IBM I. And when you decide to encrypt the field, you just take it from here and move it here and encrypt it. And in this way, you are sure that you have covered all the fields that need encryption. So, actually, if I had more time, I would have shown you some more of the product itself. My intention was to show you how we find sensitive fields and how we define authorities to see data. This we have seen, and how we do the encryption, and we see the result of the encryption. You know what? Let's spare a minute or two to see how we find sensitive fields. In order to find sensitive fields, I go here to the collect. I decide that I will work with some production libraries. So let's take SMZ for our demonstration. It will be good enough. I will take SMZ TMPA, edit as the library to be checked. I will identify some fields. I'll take F6 and I'll call this demo number sign IP. And I'm interested actually to show you that I'm able to find all the IP fields in the application. IP is always, I'm speaking about IPv4, so it always comes with a 3-digit dot 3-digit. So it must be alpha, it cannot be a numeric field. I will mark it as alpha. I know the length, the minimum length is 15, but actually the maximum length is 15, but most people make mistakes and thinks that it is 16. So I'll write the range, this is okay. Now I will go down and say, okay, I'm looking for something which contains IP, so sorry, not credit card, as part of the field name, or address as part of. I can look also if there is an IP in the text field or address, and I press the enter key, and as soon as I do this, I get here a list of all the fields, and as you can see, most of them are IPs. Okay? And I can decide whether they are IPs or not IPs, and for example, actually here everything is IP or IP in 15 or 16 bytes. So this is good. I have a recount and I can work with, and the minute that I have selected some of them, they become with an arrow and they will be fixed, and they will be candidates for the encryption. Actually, I finished this presentation showing you the part of iSecurity which specialize with field encryption or column encryption. It is based on the IBM Field Proc addition to which was started in release 7.1, and I'm ready to answer any question which you might have. I see here also already some questions. Let me read them. is there a difference in performance between select asterisk from instead of select not encrypted field from? Of course. Actually, when you write when you use SQL, if you mention a field name, it will be decrypted as per the needs. On the other hand, if you do not mention the encrypted fields, then the process which is related to this field will not occur. So if you write select asterisk from a file, asterisk means all the fields, yeah, from a file which has several fields being encrypted, then after doing so, the process of decryption will occur to the number of times that you have fields that are encrypted. On the other hand, if you just mention select and you specify the list of fields which are not encrypted, then that process will not be consumed. If you have any other question, please write them on the chat, and I'm observing the chat now, and I'm ready to answer them. I will also open all the microphones, so if you feel better asking them verbally, you are invited. Okay, I have here a question, again regarding to the consumption of resources by encryption. Well, there is always a consumption when you get something else, but it is absolutely, there are no guidelines which can be easily activated, like, okay, you will use 10% or 2% or 5% more of CPU or disk space. So I do think that a POC is required in such situation, and I do think that it is needed. The good news is that prospects who have tested several vendors and also tested our solution, one even wrote his own encryption and decryption tool, they all said that our solution is the fastest which they came across. Okay, first of all, I would like to thank you all for joining today. I appreciate it. I appreciate the time that you invested. I know that we are all busy. I hope it's good for you. We are open to questions, and if it is necessary, please do not hesitate. Just send the question, and here comes another question. And the question, is it necessary to put the manager in a different LPAR? Absolutely not. Actually, the presentation which we saw here in this screen is in this presentation. Just a minute. Okay, I have to close this. On this one, as you can see here, we have both local, which means everything is on a single LPAR. We don't have to move anything to any other LPAR. It works fantastic. The idea is that if you want to be more secure, you can at some point move one of them or both of them to a different LPAR. Any more questions? Any other questions? Thank you very much. I wish you a fruitful day. Goodbye.